Hello, children. So continuing from where we left for polynomials best PYQs. So let us look at this assertion and reason question. If the graph of a polynomial touches x-axis at only one point, so it is touching x-axis, let's say at only one point, then the polynomial cannot be a quadratic polynomial. It can be a quadratic polynomial because if it is touching and going the x-axis, it can be a quadratic polynomial. So this is false. Reason, a polynomial of degree n can have at most n zeros. That is correct. Can have at most n zeros. So if the polynomial is of degree 2, it can have maximum 2 zeros. And when it is touching and going the x-axis at this point, so 2 equal zeros, or you can say 1 0 only, because both the zeros will have equal value. So the reason is true. So option D. Let us look at question number 7 now. Okay, this is very easy. So I think you people can do this on your own. Just simple concept of alpha plus beta, which is minus b by a, and alpha beta is c by a. Simply you have to put in the values. I'm telling the answer as well. You will get option C. In case you don't get it, please let me know. Next. Now this question, alpha and beta are the zeros. Alpha plus beta is equal to alpha beta. So basically indirectly they are saying that sum of the zeros is equal to the product, and we need to find the value of k. Now if alpha plus beta is given to alpha beta, so what can I say? Alpha plus beta is minus b by a. So 30 by k is equal to alpha beta is c by a. So 45k by k, basically 45 only. Right? So we can say that k is equal to 30 by 45, which is 15 times 2 and 15 times 3, 2 by 3. Then moving on to the next one, always pause the video, do the question, and then look at the solution. Ax square plus bx plus 2a by b is the given polynomial, and the zeros are reciprocal of each other. So as you had seen in the one-shot recap that we had already discussed, that whenever the zeros are given as reciprocal of each other, we have to simply take alpha beta as 1, product of the roots as 1. So product of the roots is c by a, right? So let's see what is c by a. C is 2a by b by a, and this is equal to 1 because the roots are reciprocal. So 2a by b into 1 by a is equal to 1, and simply to say that b is equal to 2. All right. So next question. If the sum of the zeros of the given polynomial is root 2, so in the given polynomial sum, alpha plus beta is given as root 2, 2x square minus k root 2x plus 1. So that means alpha plus beta can also be written as minus b by a. So minus of minus k root 2 by 2 is equal to root 2. Root 2 and root 2 gets cancelled. Minus minus becomes plus. K is equal to 2. Option number B. Then the last but not the least for this one, zeros of this polynomial. So let's say this is px, x square plus px plus q. The zeros of this polynomial are twice the zeros of this next polynomial. So if I consider the zero of qx as alpha and beta, so that means the zeros of the first polynomial are 2 alpha and 2 beta. That is what the statement is saying. The zeros are twice of this. So I'll go to the second one first. Find the alpha plus beta here, sum, which is 5 by 4. And then for the first one, it will be 2 alpha plus 2 beta. So that means twice of alpha plus beta is from here. 2 alpha plus 2 beta. 2 of alpha plus beta is going to be the sum, which is equal to minus b. Let's just substitute the value of alpha plus beta here, which is 5 by 4. So 2 into 5 by 4 is equal to minus p, or I can say p is equal to minus 5 by 2. Thank you, children.